Next, we're moving on to 7.3, 7.5. I put them together. There will be quite a bit of homework to do because they're 2 exercises, but they are big exercises. You do want to do them all. Exam, they love to ask questions on this one because we're the combined incline plane. If you forgot what we've done, we've actually done some incline plane, which is last lesson on this one. Hopefully you remember. This time has no friction in the previous example, but today we're going to mix it with the friction. Hopefully you do remember the formula for friction, F equals mu R. So F stands for friction, mu stands for coefficient of friction, and R stands for reaction. Just one point for this type, for this lesson is that when you say on the point of slipping, that's the same as saying limiting equilibrium, the same as the word equilibrium. So on the point of slipping, that means you're about to slip, but you're not. So we don't care if we don't care if the object is about to slip. All we care is, it's not moving. If it's not broken, don't fix it. That kind of concept. So it's not moving. Yeah, who cares if it's on the point or not? But it means equilibrium. Equilibrium means up equals down, left equals right. Or essentially, the reason being up equals down, left equals right is that because acceleration in both directions is 0. When A is 0, F equals ma, there is no acceleration. So both sides of the force equal each other. Right, so enough of introduction. Let's go through the example. A box of mass 10 kilogram rests in limiting equilibrium. Limiting, who cares? Limiting. Equilibrium. Kidding. Technically there is a difference, but for airborne mechanics, we don't need to know. On a rough plane, rough means there is a friction. Okay, friction, smiling now because friction say it's like it's time for me to come to change the dynamics of the calculation. So Superman always arrive late, that kind of concept. So incline at 20 degrees above the horizontal. Find the coefficient of friction above the box and the plane. So let's draw a diagram. So a box in here, which is 10 kilograms. So 10 kilogram, 20 degree. Right, so forces. Draw the forces for me on the incline plane. Pause the video, draw the forces on the incline plane for me. Right, so the forces should be, remember, 10g cos 20. So mg cos 20, mg sine 20, reaction. Anything that's extra. So in here is a rough plane. Now, you need to think about the box of mass in here, without friction, what will happen to the block of mass? It will slide, right? So without friction, it will slide. But the fact that it's not sliding, it means friction is helping to stop it happening. So where's the friction? Friction must be this way. So on here, you might want to write down friction is facing upwards because I'll let you write down the answer. I'll let you finish off. Okay, you can do it yourself. Okay. Next, so this type of question, this type of notes is what you should be putting in there. So why am I doing that kind of, for example, in the previous example in here? Why do I have to resolve? Why, where did that come from? Why upwards equal downwards? So the mechanics, you're always asking yourself why and why and why and why. Okay. Even when you're eating, you should be thinking about, okay, why am I eating? I'm just kidding. Don't be a freak. Next, part A, find a coefficient of friction between the box and the plane. So axes, let's draw a pair of axes. So axes, am I sharing screen? Yes, I am. So axis is here. Oops. X is here, so no forces need to be resolved. Again, ask yourself, why is there no force need to be resolved? You can draw a force diagram if you want to, but I'm going to skip that because I'm going to do up equal down on y. So R equals, now again, questions, why up equals down? Why do we not have to use F equals ma? So R equals 10g cos 20 degree. Just to answer the question for you, why is that up equals down? Because of equilibrium. Equilibrium means A is 0, so we don't have to use F equals ma. When there is acceleration, then we can no longer use up equals down or left equals right because there will be acceleration. Okay, so 10g cos 20 is not a nice number. We're going to leave it like this. Okay, so reaction. And then left downwards equals right. So left, we've got 10G sine 20. Great. Right hand side, we've got friction. So we know friction equals mu R. So I'm going to replace friction equals mu R. So here, F equals mu R. Sub it in. So what's reaction? Reaction is 10G cos 20. So I can use this in here. Actually, a better way would be using highlighter. So color coding. That's a powerful way to help you to coordinate things, so you don't have to, help you coordinate things. Where does R come from? So 10G, 10G sine 20 equals mu times 10G cos 20. So divide that over. So 10G sine 20 over 10G cos 20 equals mu. Plug it in a calculator. You will see the answer. There was a disruption. Carry on. So put in calculator 10G sine 20 over 10G cos 20, you will get mu equals 0.36. It's not an exact value, so needless for me to say, store it in a calculator. Okay, store it in a calculator, 0.36, because we might need it later. All right, so that's the answer, part A. Part B, let's read the question. A horizontal force of magnitude P is now applied to the box. Given that the box remains in equilibrium, find the maximum possible value of P. So let's extra force, extra diagram. So we've got our own 10 kilogram in here. Again, you've got your 10G cos 20. No matter what happens, hurricane, earthquake, tsunami, we know the three forces are always going to be there waiting for you. Right, so these three forces are going to be there. But this time, we have our, actually, let me put it a bit lower. However, this time we have a horizontal force of P pushing in. That means P got a new force pushing like this, P Newton. Okay. Now, first question for you is, I would like you to think about where is the friction? Which side is the friction on? The answer to this will be, it depends on the question. This time it's a find a maximum possible value of P. So you could imagine, P is a large value. That's how you would think, that's how you should be thinking. Okay, so when you're thinking P is a large number, if P is a very large number, that means the box is very likely to be pushed up. But the fact that it's not being pushed up means the friction is helping against it. That means friction will be down as well. All right. Now, another question. So that's the diagram. Another question could be, if the question says find the minimum. I'll use different color. Find the minimum possible value. That means you can think about P being a very small number. If they want you to find a minimum value of P, it means P is a very small number. If P is a very small number, imagine you're pushing a box, but using just a tiny finger, try to poke it up. Obviously, the P Newton will not be strong enough to withhold, to stand against the 10G sine 20. So if P is a very small number, that means the 10G sine 20 will still be bigger than P. So it's very likely to slide. So if P is a very small value and the block is about to slide, then the friction will be the other way, which is that way. Just to clear concept in here. The reason that friction is now acting downwards is because it's a maximum value of P. It means P is a very big number. So if P is a very big number, it overcomes the 10G sine 20. So the block is very likely to move up, but it's not moving because friction is against it. Okay, so that's why people find mechanics difficult, because there's a lot of imagination going on in there. Yeah, we're crazy people. We are. I love mechanics, but I don't like, it's a math side of mechanics I like. Next part, same thing. So once you've got your diagram sorted, the next thing is you have to do your axes. Okay. You tell me, any force need to be resolved? Yes, P Newton need to be resolved. So P Newton, let me here. So y going down, x going up. That degree is 20 degrees there, so that's 20 degrees. So I'm going to resolve P. So first step, resolve P. I'm not going to draw the diagram, draw a triangle this time. So x equal P cos 20 and y equal P sin 20. Next step, if you like to, force diagram. So on the y-axis, we've got reaction upwards. We've got 10g cos 20 downwards. So I'll put a little tick next to it. Done, done. Next one, 10g sin 20 on the left, on the x. So on the x-axis, 10g sin 20. We also have friction. So put a tick. Means done. Friction. So what else? What about P? So the P Newton, P cos 20 is going upwards. So P cos 20 in here. That means it's done. P sin 20, y-axis, y is going down. So P sin 20 is, oops. A bit of technical issue. P sin 20 is going down. Okay, so P sin 20 degree. Okay, right. So that's enough. All the forces. So all the forces are included. Let me just count again. 1, 2, 3, 4, and then P makes 2, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. Yep, 6 forces on the force diagram. We're all completed. Next step, upward force equal downward force. And so on the y-axis, you can say up equals down. So R equal 10g cos 20 plus P sin 20. Two variables, we can't solve it, so we're going to leave it like this. And sine and cos 20 are not nice numbers, so we're going to leave it like leave them. Okay. So some people, when they're in bad temper, you want to leave them like let them cool down a little bit, and then you can not use them. Sorry, not numbers. They're not numbers. Then you can talk to them later. So left equals right on the x. So 10g sine 20 plus friction equals r cos 20. We know friction could be written as mu r, so I'm going to rewrite again. But instead, this time I'm going to plus mu r equals r cos 20. Okay. Is it r cos 20? Sorry, it's not r cos 20, is it? It's p. So p cos so p cos 20. So p cos 20. Right. Next, reaction could be replaced in here. So color coding again. So this R can replace R in here. So I'm going to rewrite the whole thing. It's going to be quite a long equation. So get used to it. You need a lot of precision on writing the steps. 10g sine 20. So pay attention. You don't want to skip. Sometimes students will stop writing a G, copy the wrong things. Yes, it's a very simple skill. Copy the previous step, but students will make a mistake in it, including myself. Plus mu times R. R is now 10g cos 20 plus P sine 20 equals P cos 20. Do we know the value of mu? Yes, we do from part A. So why can we reuse the value of mu equals 0.36? Because the mu represent the friction, coefficient of friction between two surfaces. It's a surface of 10 kilogram and a surface of the plane. We're not changing the material of the 10 kilogram block, nor we are changing the surface, the material made by the inclined plane. So the mu stays the same. Mu is 0.36. So what I'll do is I would probably, put this in a calculator. So 10g sine 20, put in a calculator, 33.51. Now you should be storing a lot of values in the calculator. I'm going to store this in A, right? Plus 0.36 times 10g cos 20. So 0.36. Let me write this: 10g cos 20 plus P sine 20 equal P cos 20. So I'm going to multiply this into it. So 33.51 remains the same. Plus, go remove the A. So you should be storing these. If the number is not exact, you should be storing in calculator. 0.36 times 10g cos 20 is also 33.51. 0.36 times sine 20 is 0.124, so it's 0.124p, which equal p cos 20. So p cos 20, actually cos 20 is 0.94, so I can do that. So I'm going to do 0.94p. And then you should be collecting like times the left hand side, 33.51 plus 33.51, that's 67.04. On the right hand side, 0.94p, subtract 0.124p, that will give you 0.815p. Why is there 5? Because the numbers, the decimal points. So 67.04. So if you divide by 0.815, you get p equals 82.2 Newton. So in this example, you've not only you have to know how to use the previous steps from 7.1, 7.2, but also very intricate decimal numbers you're dealing with. So get used to storing numbers in a calculator and use them as your good friend instead of typing out your name in a calculator. So again, first step, put in all the forces. Second step, think about where the force is in, and then second step, put a force diagram, left equals right, up equals down. Okay. So just carry on. Example number 2, a particle of mass 5 kilogram is projected up a rough slope at 60 meters per second and comes to rest at point P after 5 seconds. Given that the slope is inclined to 10 degrees to horizontal, find the coefficient of friction of mu. So again, let's draw a quick diagram to see what's going on in here. This time we've got 5 kilogram. So on the slope, again, without doing anything, the 3 stable forces, 5g cos, this time is 10 degree, reaction, and 5g sine 10 degree. Okay, right, it's a rough plane, so it's projected up actually. So yes, even though there's no force pushing up, but yes, imagine there's an invisible hand that's pushed the block upwards, and then we record it from there. So yes, even though there's no force pushing it up, but we're still moving it up. So moving up, that means we're going up by 60 meters per second. Now, if it's moving up by 60 meters per second, in other words, the reaction, sorry, not reaction, the friction will be against it. That's the friction, right? So that's the friction. So, right, now because it's moving, so it's no longer equilibrium, okay? If it's no longer equilibrium, you have to be mindful. Right, so what can we do? Well, you see speed, you see time. What's the first thing come to your mind? You've learned in year 12, Subat. Okay, so Subat. So we're going to do Subat. But the question is what you are working out in here. We know time is 5. We start from rest, didn't we? It comes to rest. So we start from 16. It comes to rest V. So what are we trying to find in here? Displacement doesn't help us because with force, F equals ma, the variable you want is the acceleration. So using V equals U plus AT, 0 equals 16 plus A times 5, A will equal 3.2 meters per second squared. So, sorry, it should be negative. Yep, because bring it 5. Yep, negative 3.2 meters per second squared. That means it's a deceleration. Which does make sense, you know, because deceleration means the block is moving up and there's friction, it comes to rest. So it will be deceleration. Because we start from 16 and it comes to rest, so we're slowing down second by second. So once we've got that, then we can look at the force side of things. Do we need to resolve any forces? So let's draw an axis. Do we need to resolve any forces? No, we don't. All the forces are in line, okay? Then the next step will be draw a force diagram. You can draw one, but because all the forces are on there, probably we can skip it. So step 3. Now, this equilibrium. This is not equilibrium. So upwards will still equal downwards because no acceleration in the y direction. So upwards equal downwards. So R equals 5g cos 10. That's a given. Okay, so we don't have to do anything. However, okay, for the x direction, we have to use F equals MA. Now, I do want to put a note in here. Cannot make left equals right because not equilibrium. So therefore, we have to use F equals MA instead. All right, so we're going to use F equals MA instead. So F equals MA. So what's the F then? The F, because moving upwards, so any upward force will be positive, any downward force will be negative. So forces will be negative 5g sine 10. So negative 5g sine 10, subtract F. Now, I will say again, why is it negative? Because we're moving up. If it's moving up, any forces downwards opposite to it will be negative. So it's negative 5g sine 10, negative F. There's no force moving upward, so all negative. M is 5, acceleration is negative 3.2. So put in the calculator. Oh, actually, before we do that, so if we move the 5g sine 10 to the right side, so negative F, I'm going to change to mu r. So negative mu r equals negative 16 plus 5g sine 10 degrees. So I'm just doing a bit rearranging. I know r is 5g cos 10. So let's use the power of color coordinating again. So r equals 5g cos 10. That'll be r. So minus mu times 5g cos 10 equals negative 16 plus 5g sine 10. Divide negative 5g cos 10 over, so mu equals negative 16 plus 5g sine 10 divided by negative, don't forget negative 5g cos 10. Put in the calculator, and then you should be able to get 0.155 as your coefficient of friction. You know this is correct. There's no unit. Sorry. You know it's correct because sort of correct because the mu value has to be between 0 and 1. Store in the calculator because there's no exact value. All right. Next part. Part B. State with supporting calculation whether the particle will remain at rest at P or will begin to slide back down the slope. So where is the point P? P is the highest point. So the particle, so let me, favorite part of the mechanics, we can draw some diagrams. So here, that was original. Now P at this point, that's point P. The particle is here, it stopped. So the question is asking, is it coming back down or does it stay there? So which one is it? Now, how can we tell if it's sliding down? Or judged by the forces. For example, if you are standing on a slope, okay, that's you. That's the mg sine theta. Now, the fact that you're not sliding, that means the friction is strong enough to withstand your weight pulled by the gravity. But if you slide, that means mg sine theta is bigger than friction. So so it means if mg sine theta is greater than friction, you slide. If mg sine theta is less than or equal to F, is less than equal to, because if friction is just enough, is equal to mg sine theta, you stay. So let's come back to this question. So on the top of at the point P, we've got our mg sine theta, which is 5g sine 10 degree, 5g sine 10 degree. Now, this time at the highest point, friction will now be acting in the opposite way. So that's a tricky part of this question because the friction suddenly changed side. So it's a snake. So friction is opposite because friction is trying to stop it sliding backwards. A snake or friend, I don't know. You still have our reaction and your mg cos 10 degree. So let's do the calculation. So we presume, okay, so what's F then? So for reaction, so we know reaction equals 5g cos 10 degree. So therefore, F equals mu R equals 0.155 times 5g cos 10 degree. Put in the calculator, that's 7.49 Newton. Now, what about the weight? What about the weight pulled by the gravity, the gravitational force? 5g sine 10, put it in a calculator, that will be 8.509 Newton. So unfortunately, because 8.509 is bigger than 7.49, therefore it slides. So in a nutshell, it means that the weight pulled by gravity is 8.509. The friction can only go as big as 7.49. So anything that, because the pulling force bigger, the particle will slide. Okay, so slide. You can give a reason to yourself. Okay, because the friction is not large enough, or what's the word? Great enough to overcome the pulling force by gravity. Okay, so in real life, this block will slide. All right. So this, at the end, I only went through 2 questions, but you will start off with some easy questions, chapter 7.3, 7.5, so exercise 7C and exercise 7E. And in lesson, I will go through some exam questions with you. And that's the end of chapter 7.3, 7.5. A lot of questions to be done because this is a big chapter. You can see the calculation is not easy. All right. But we'll spend some time in lesson 2 together.